Hey guys, welcome to another math lesson with HK Math and Science. This video will be about angles and triangles, and the learning intentions for this video is to review types of angles and triangles, and by the end of this lesson we should be able to work with complementary, supplementary, vertically opposite and angles in a revolution, be able to use the angle sum and other triangle properties to find unknown angles, and finally be able to apply the exterior angle theorem. So just pause the video here and take a couple of minutes to write these down. Alright, so let's start the lesson off by going through a few angles. You really need to know these, so let's copy and draw this table out into your books. So the first type of angle is an acute angle, and that's an angle that is less than 90 degrees, like the one over here. A right angle is an angle that is exactly 90 degrees, so like that. It's usually represented with a little square like that. So remember, acute is smaller than 90, so it'll be smaller than that. And obtuse is an angle that is greater than 90 degrees and less than 180. So that's bigger than that, but smaller than this one here. So that brings us to a straight angle, which is an angle that is exactly 180 degrees. So acute smaller than 90, right angle exactly 90. Obtuse between 90 and 180, and straight angle is exactly 180 degrees, or just a straight line, like it says in the name there. Reflex angle is an angle that is greater than 180 degrees and less than 360. So anything bigger than that. And revolution is an angle that is exactly 360 degrees, or pretty much a full circle there. So just pause the video here and just draw this out into your books. Alright, so these are some more angles that we need to know, and they're generally known as angles at a point, because if you have a look at them, they're all based on a point like that. Here, there, and there. So complementary angles are angles that sum to 90 degrees. So if you add them together, they will give you 90 degrees like that. Supplementary, they add to 180 degrees. These two would give you 180. Revolution is when all the angles added together sum to 360 degrees, like this one here. And vertically opposite, when you draw two straight lines crossing each other. This one states that angles that are directly opposite, like that and like that, they will be the same size. So just draw this down into our books as well. So I'll just get rid of the pencil marking so it's easier for you to see. And let's just draw this. Alright, now we know the different types of angles at a point. Let's go through a couple of example questions. So the first one is going through the definitions of supplementary and complementary angles. So for an angle of sine 47 degrees, determine the size of its supplementary angle. So we can find that by doing 180 minus 47, because the total is 47. And to get the other angle, we'll have to subtract 47. So that gives us, if you work that out, that will give you 133 degrees. For its complementary angle, the total is 90 degrees. Just looking at the slide before again, sums to 90 degrees there. So let's have a go at that one. 90 minus 47. If you work that out, that will give you 43 degrees. Alright, now it's your turn. Exactly the same deal here. For an angle of sine 72 degrees, determine the size of its supplementary angle and complementary angle. Let's just pause the video here and take a couple of minutes to work these out by yourself. Alright, so for question A, supplementary, that is when angles total 180 degrees. So we'll do 180 minus this, which gives you 180 minus 72. If you work that out, that should give you a value of 108 degrees. Give yourself a tick if you got that one correct. Alright, now moving on to question B. Remember, complementary is when they equal or add up to 90 degrees. So that'll be 90 minus 72 to give you the unknown angle, and that will be 18 degrees there. Give yourself a tick if you got that one correct as well. Alright, now we're going to move on to the types of triangles. So there are a couple of different types of triangles, and we do need to know all of these. The first one, they're grouped in as different angles. There's acute angled on the left, right angled in the middle, and obtuse angled on the right. So acute angled triangles, all angles are smaller than 90 degrees. So you can see here, they're all smaller than 90 there. So there's two types of acute angled triangles. The first is scalene. That means all sides and angles are different sizes. So that angle, that angle, that angle, they'll all be different. And the length of all the sides will also be different. Another acute angled triangle is known as the equilateral triangle. That's where all the angles are the same size. That will be 60. And all the side lengths are the same as well. And there's one more known as the isosceles triangle. This is when two angles are equal and two sides are equal and one is different. So we can see here, shown by the lines there, these two sides will be the same length and those two angles will be the same size. Now moving on to the next group of triangles, we have the right angle triangle, and this one is when a triangle has one 90 degree angle. So this one is over here. shown by the square there, and this one is down here. So right angle triangles can either be scalene, like we said here, all sides and angles are different sizes, or it can be isosceles. Notice how there's two equal angles and two equal side lengths. And finally, we have an obtuse angled triangle. This is when at least one angle is bigger than 90 degrees. That one's over here, that's bigger than 90, and this one's also over here. This can also be in scalene. Once again, all sides different and all angles different, or it can be isosceles, two sides are the same and two angles are the same. A key point for this is that the sum of all the angles in a triangle is always 180 degrees. So if you add all the angles in a triangle, no matter what triangle it is always going to give you an angle total or angle sum of 180 degrees. So let's pause the video here and write this down. This will be very important. Alright, now moving on, let's have a go at a couple of example questions. So name the triangles shown here and determine the values of the polynomial. So step one is to name the types of triangles. This one, notice how it says all the sides are the same. That means it is an equilateral triangle. And equilateral triangles have all the same angles, so that means that angle is also 60 degrees. The other way we could have found that out is it's going to equal 180 when you add them all together. So the only way to get a total of 180 is to do 60 plus 60 plus 60. Alright, now let's move on to the next question. From the line markings, we can see that two sides are the same length. So let's go to the slide before. It says, when two sides are of the same length, it says it is called an isosceles triangle. So this one would be isosceles. And another component or characteristic of an isosceles triangle is that two angles are also equal. So we have one angle here, this is no way the same as that. So that means these two will be the same length. So we've technically got two r's. So we can do r plus 120 will give us a total of 180 degrees. Remember, the angle sum of a triangle is 180. And let's work that out. R plus r is just 2r, and we have 2r plus 120 equals 180. Let's get rid of the 120 on this side by subtracting 120 on both sides. That will give me 2r equals 180 minus 120. That gives me 2r equals 60. And then divide 2 on both sides to get rid of the 2 here. Let's do that. That gives me r equals 30 degrees. So we now know that r equals 30 degrees there. And moving on to the last one, all the side lengths are different here. So this one is a scalene triangle. All the angle lengths are different as well. So we need to add them all together to get 180. Let's do that. 50 plus 60 plus s gives me 180. 50 plus 60 is 110. So 110 plus s is going to give me a total of 180. S equals 180 minus 110. S is going to equal 70 degrees. And one thing I forgot to do with these questions was to label the angles of the triangles. So like they did here, acute angled, right angled, or an obtuse angled triangle. So let's just change it up a bit. This one was obtuse, so make sure you include the angle name in there as well. So this will be obtuse isosceles triangle because there's one obtuse angle in there. This one will be an acute scalene triangle. So please make sure you include that and don't forget it like I did. Alright, so now it's your turn. Let's just pause the video here and have a go at these by yourself and just unpause it when you want to go through them with me. Alright, starting with question A, we know this is a right angle triangle to start off with. So this will be a right, and all three side lengths are different. So this will be a right scalene triangle. Give yourself a tick if you got that part correct. Let me just write that out properly. And the next part of this question is to find out the angle size of A. So if you add them all together, it's going to equal 180. We know that's 90 because that's a right angle. So we have to do 90 plus 25 plus A gives me 180 degrees. 90 plus 25 is 115 plus A equals 180. A is going to equal 180 minus 115. Let's quickly work that out over here. 10 minus 5 is 5. 7 minus 1 is 6. So A is going to equal 65 degrees. Give yourself a tick if you got that correct. Now moving on to question B. I'll just rub this part out. Let's start off with what triangle this one is. So to start us off, we know that it is an acute triangle. All angles are smaller than 90. So let's start off with acute. And this one is an isosceles triangle because two sides are the same length here. So it's an acute isosceles triangle. Now let's solve the angle size for B. Remember, for isosceles, two of the angles are the same size, so that will also be B. So we're going to have B plus 20 is going to give me 180 degrees. Alright, so that gives me 2B plus 20 equals 180. Let's move 20 to the other side. 2B is going to equal 160 degrees, and B, we need to divide 2 from both sides to get rid of 2 here, is going to give me 80 degrees. So B is in fact 80 degrees here. Give yourself a tick for the name and the angle size. Now moving on to the last question. This one is obtuse. Notice how that's bigger than 90 degrees, so we know that the first component is an obtuse triangle. Next, all the angle sizes are different here, and the side lengths are different because it doesn't have any markings to show that they are the same. So this one is a scalene triangle, so obtuse scalene triangle. Now to find the angle size here, we need to add these all together. That will give us 180, so we can subtract it from 180. 140 plus C plus 18 gives me 180. 140 plus 18 gives me 158. Plus C gives me 180. And then we can do C equals 180 minus 158. Let's quickly do this up the top. 180 minus 158. That gives me 2 there. 7 minus 5 is 2. So we know that angle is 22 degrees. So C is going to equal 22 degrees. Give yourself a tick for the name and the angle size. Alright, so we're almost at the end of the lesson now. Just bear with me for a couple of minutes. We're almost there. So we need to go through one more thing, and this is the exterior angle theorem of a triangle. So to know what this is, we need to first know what an exterior angle is. An exterior angle is formed by extending one side of a shape. So notice in this triangle, we extended this side here. That's gone out that way. So we could have more exterior angles, we could draw more. Another one would be up here. If we extended that side, this would be an exterior angle. If we extended this side like that, that would also be an exterior angle. So if we just extend the side, the angle it forms is the exterior angle. I'll just do one more example. That one here, that could also be an exterior angle. Alright, now moving on to the exterior angle theorem. The exterior angle theorem of a triangle states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So this states that this exterior angle is equal to C plus B. If we had that line here, it will be that exterior angle equals to that plus that. Alright, so let's just pause the video here and just write this down into our books. Alright, now keeping this in mind, let's have a couple of questions. Find the value of each polynomial and give reasons for your answer. So remember the exterior angle theorem. For question A, that's the exterior angle here. That would equal that plus that. So Y would equal 55 plus 90. Let's work that out. I'll just do it up here. 90 plus 55. 5 plus 0 is 5. 9 plus 5 is 14. So we have Y equals 145 degrees. For question B, this one is a little bit more difficult. It doesn't actually use the exterior angle theorem. It uses your knowledge about vertically opposite angles. So make sure you know this one. Remember, vertical opposite angles are equal. So keeping that in mind, let's have a go at this question. So this one is an isosceles triangle. So two of the sides and angles are the same. That means this angle and that angle will be the same here. So that's also 47 degrees. Keeping that in mind, we can find the angle size of that. That will be 47 plus 47 plus, I'll call that x because that's going to equal that, equals 180. Let's try 47 plus 47. Up here, 7 plus 7 is 14. 4 plus 4 is 8. Plus 1 is 9. So that gives me 94 plus x equals 180. Now let's move 94 over. That gives me 180 minus 94. X is going to equal, let's do 180 minus 94 there. Can't do 0 minus 4, so you have to take it from here. 10 minus 4 is 6. 17 minus 9 is 8. So we know x is going to equal 86 degrees. Alright, now let's move on to the last set of questions. This one's time for you to have a go. So remember, this one uses the exterior angle theorem, whilst this one uses your knowledge on vertically opposite angles. Have a go at these and just unpause the video when you're ready to go through them with me. Alright, so question A, that uses the exterior angle theorem. This plus this is going to equal that. Alright, so this time we've got the exterior angle, we don't have that, but we still know that 70 plus x is going to equal 152. So we can do x equals 152 minus 70. So x will equal, let's work that out up here. Excuse me, I don't know why I did that. 2 minus 0 equals 2. 15 minus 7, that gives me 8. So we know x equals 82 degrees there. Give yourself a tick if you got that correct. And moving on to the last one, we know that's 40. We're looking for what y is there. So we know from this information, we can find out that angle and that angle. Remember, this is a vertically opposite angle, so that's going to equal 40 degrees. This one here, that's a straight line, so that's pretty much a straight angle. So that means this is going to equal 180 minus 120. So that gives me 60 degrees there. That will be 60 degrees. Using that, we can find out what that angle is. 40 plus 60 plus that is going to equal 180. Plus, I'll just call it, let's call it A. Equals 180. 100 plus A equals 180. So A is going to equal 80 degrees. So we know that's 80 degrees. So with that, that's also a straight line. We can find out what y is. Y is going to equal 180 minus 80. That gives me 100 degrees. Give yourself a tick if you got that correct. Just to make this last part a little bit more clear, I got to this because y plus 80 is going to equal 180 degrees because that's a straight line, meaning it's a straight angle. So that means that will bring me to 180 minus 80. I should have done this step before I went to that. And that gives me y equals 100 degrees. Hopefully that's a little bit more clearer now. And that brings us to the end of this video. Thank you guys for watching and staying put till the end. Hopefully you guys did learn something from that, and you can work with complementary, supplementary, vertically opposite, and angles in a revolution. You can use the angle sum and other triangle properties to find unknown angles. And finally, can apply the exterior angle theorem. Thank you guys for watching, and I'll see you guys all back online.